I'm Daniel, and that sounds really loud, sorry. I'm going to talk about making iOS scriptable apps today. So first, a little bit about me. I make an app called Issues, which is a bug tracking app for GitHub, Bitbucket, and Codebase. So if you use any of those services, you might want to check this out, because you can easily deal with the issues on those systems. And if you really like the icon and you like putting stickers on your laptop, there's some stickers at the end on the desk that you can take at the end. So feel free to come up and just help yourself. There's a few there. So the first question you might ask is why actually provide scripting on iOS? Why allow your users, who usually interface with the app, just as is, to be able to get in and dig deep into your data model and cause all kinds of havoc from the inside? Why would you let them have that kind of power? And the first point is really, it will empower them to be able to do greater things than they're able to with just the interface that you're providing into the app normally. And this is going to grow a community around your app. Right? Fundamentally, I've seen a lot of apps that provide very decent scripting support, and they make and build this community and support it in a way such that the community then builds features that the community wants, that not necessarily the company wants to build themselves and support long term. The community also provides this kind of way of beta testing features. So if you've got a feature that you think is a great idea, you might want to put it into the app properly, but you could build a plugin or script it such that you could test that out before releasing it properly. And again, up here, you could debug the app straight on the device without having a debugger there, because you can access the scripting panel, pull it open and say, okay, what is my data model doing right now, and why is this bug manifesting in the UI in such a way? And finally, it's fun. It's stupidly fun to be able to code your app on the device next to the app, inside the app, and it's all a bit weird, but you're providing that interface for yourself, and you're building a tool for yourself to use, and there's something really fun about that I really enjoy. So I'm going to talk about what kind of options we've got for scripting languages in the app. So the first is obviously Swift. It's open source, so feasibly you could put that compiler into the iOS app and allow users to write Swift code to code against your code, which is written in Swift. Yeah, that sounds like a great idea. JavaScript, which is the complete opposite of Swift, believe it or not. Swift is a very type-safe language. JavaScript is not typed at all. We have Python and AppleScript. If anyone's used AppleScript, has anyone used AppleScript on the Mac? Yeah? So one person. So if we were going to put AppleScript support into our app, this audience wouldn't know how to code for it, and presumably we're all fairly technical people. And frankly, I've used AppleScript for a while on the Mac a long time ago, and it was hard, and you have to look up stuff on Stack Overflow. You just copy and paste from random blogs that may or may not exist anymore. You may have bookmarked stuff that just completely disappears. AppleScript support on the Mac, at least, is waning anyway. So out of this list, we've got something that is very old, unsupported. Python, I think, is probably quite obscure, as much as developers of Python would love to say otherwise. It's a nice language, but it doesn't have that broad appeal. We're trying to appeal to as many different users as we can, because we don't want to make something that is constrained to just a limited set of people. That argument can be also applied to Swift, but we've also got other problems, like Swift keeps changing, so how do you support a changing language in your app? You could dish out a version of Swift, say Swift 3 or Swift 4, and the next version comes along and makes subtle changes that's going to change everyone's scripts. And if we're giving out the ability to do scripting to every user, they might not be technical enough to actually keep up with Swift. So I'm going to suggest that JavaScript is the one we're going to choose, and that's the one I'm going to talk about. And it has some fairly decent properties. So the first one is that it's actually familiar to a lot of people. As I've said, loads of people know JavaScript. They come in, they hack away, they make terrible code, possibly. They make really good code, but they make code that works using JavaScript. It's very flexible. It's very forgiving. You can give something that wants a string a number, and JavaScript in a lot of cases will just deal with it. Users don't need to know what a type is. They just know that they're getting something, and they can do something with that. In terms of iOS and on the Mac, we've got JavaScript Core. So this allows you to easily bridge from Objective-C to JavaScript. And that is key. You might have noticed that we're talking about Swift, and now I'm talking about doing Objective-C to JavaScript, but that's part of the fun of this. And it's also available on other platforms. So if you've got an app that is on iOS and Android, or on Windows and the Mac, you will want to provide a scripting environment that is the same on both platforms. Users aren't going to want to learn your Swift version of scripting on iOS and maybe Kotlin on Android. They're going to want the same interface into your scripting environment. So JavaScript Core, as I said, is an Objective-C framework. It's been shipping on iOS for a few years, I think. Well, definitely a few years, but maybe a few more. And it's a wrapper around WebKit's JavaScript engine. It's available on macOS. It's completely open source. You can actually go in and look at the source code for it. And that also means that if you really, really badly wanted to, you could port it to the Mac, you could port it to Android if you had the time and resources. So it does mean that this code could be cross-platform if you've got apps on other platforms. So yeah, it's a wrapper around the JavaScript engine, and it allows you to insert custom objects into the environment. Okay, so the JavaScript engine already knows about core JavaScript types like number and string, array, and stuff like that. This will allow you to insert completely custom types into that environment. So the fundamentals that we're looking at are a JS context, which is the environment itself. That's it's going to give you a way to define all of these custom types, to execute or run a string, a JavaScript string. We're going to look at JS values, which are wrappers around your values and wrappers around JavaScript values to give back to Objective-C. And the biggest part of this, in terms of writing to make something scriptable, is JS export, which is a protocol, and it's to where you will implement to allow. Let me start again because that was bad. JS export, which is a protocol, and you will define protocols that implement that protocol, so kind of sub-protocols, and each of those sub-protocols will dish out methods and types to the JavaScript context. And most of this talk is going to be focusing about how to do that. So exporting types. As I said, we've got the JS export protocol, which is an empty protocol defined by Apple. And they've said that any protocol which, I don't know the right name for this, but like inherits from that one. Any protocol which inherits from JS export will be able to provide methods, properties, and classes to JavaScript. Then you obviously have to implement the class, which implements that protocol to provide the methods and the properties. And as I've said before, this protocol is an Objective-C protocol, and the class is an NS object. So fundamentally, if we're looking at very Swift types, this doesn't seem to gel. Okay, so imagine we have the Swift type, which is a struct, so it's a value type of position. it's got an X and Y properties, and it's got an initializer which takes an X and a Y and just sets it. It's really, really simple. It's so simple, it can fit on one slide, which is really nice. And that's kind of how I write my types, because they don't need to be big a lot of the time. So this is very simple, but we can see how this is not going to gel well with JavaScript at all. So firstly, we need to add an export protocol. So this is going to tell the JavaScript engine that there is this thing that has an initializer with an X and a Y and takes doubles, and this thing has two properties, an X and Y, in which are both doubles. They're gettable and they're settable. And what we have to provide to the JavaScript engine is an NS object, which implements this. So the way I've chosen to do it is to write an Objective-C wrapper, which is an NS object. I've called it JS position. Inside it, it takes our position value and initializes that, and has an initializer which just takes that. That allows us to convert fairly easily between a position and a JS position. What you'll notice here is that none of the properties or init method are from our JavaScript protocol are implemented in this. So to do that, we can just add a convenience initializer, which takes the X and the Y, creates our real kind of position value, and sets that via the default initializer. And the X there, we can say, we can implement a getter and a setter just using the normal value of the position. And obviously, hopefully that's going to scroll to the bottom. Yeah. You can see that the Y property was also implemented there as well. Then it's just a case of getting a JS context, setting JSPosition.self for position. So what this is going to allow users to do is use position types in JavaScript as if they were position types. And when they create a position type, it's going to create a JS position in Objective-C. And in turn, that's going to create a position struct Swift type. Okay? Which is kind of like, hey, I've got a turtle, and then that turtle's eating that turtle, and then another turtle is eating that one. So you've wrapped it so many times that you don't quite know what's going on anymore. But I think if you keep this model in mind and use it for everything, then you kind of, I don't know, it makes a little bit sense going forward. So this is the kind of JavaScript that they could write. Create a new position at 0, 0, and then you could set an X and a Y on it if you wanted to, or do something more with it. And the idea is that you could build an application which kind of gave all kinds of types and did very complex things with these things, so that you could build up a library for users to actually use and interact with that data model in your app. The kind of thing I'm using for it at the moment is I've got a drawing app, and it doesn't actually have a UI, but I do have a code editor next to it. So if I want to make changes to the drawing, I can go in and change the JavaScript code, and it kind of works as my own UI until I've kind of worked out what I need to do. But it allows me to check that all of the changes to the values inside are actually happening, and when they change, stuff updates on the screen. So you may have realized with that short example that you're going to need to export quite a few types for things to be usable, for anything to kind of give the users enough to actually do things. In my little kind of side project, I think I'm exporting maybe about 25 different types. And that gets very tedious to write by hand, which is where I found a tool called SOURCERY. And SOURCERY is an awesome code generator. It scans Swift code, and you can write templates which will generate the kind of all of the JS wrappers for you. However, the bad side is, like, that's an example of some of the SOURCERY code in my app. Yeah, it's okay to laugh. This is meant to be hilarious. So you can see there's a lot of type check in here because I've got something called a positive and a percentage, but I don't really want to reveal those to JavaScript. I just want to say, no, actually, they're effectively a double. There's handlings of string and bool, and I'm sure some of this could be tidied up. But those, 15, 20 lines of code generate that line. So these files are particularly big. But once you've got them, you could just export a new type with one line of code. And that makes it really powerful to kind of say, OK, well, all of this new functionality, I want to push that to JavaScript, and it's very easy to start exporting that stuff. I think the total lines of code in the SOURCERY file for generation is probably around 400 lines, which is quite a lot. But the generation that it's doing is probably, at this point, maybe 3,000 or 4,000 lines of code. I'll explain why that is so big in a bit, because obviously the wrapper has already fit on the slides, because there are some gotchas with this. All of these gotchas come down to the fact that JavaScript is not typed, and Swift is completely typed. So imagine we're in JavaScript, and we create a new position. If you remember, the position had the position initializer, which comes across as a constructor in JavaScript. It took an X and a Y value. So if we called that constructor with no parameters, what gets passed to JS position is not a number and not a number. And that gets pushed to our position type, and that's kind of fine with it, but it's possibly unexpected. You might be thinking, well, no position should never have not a number, because that's just unfeasible. In a graphics app, that would mean pushing something way, way, way out, or making a bad calculation. Possibly your position type is already protecting itself against having values which are not a number. So in some circumstances, this could crash if you've got a cert set up, but in general, it's just unexpected. For something a bit more meaty, imagine we had a struct type, an area type, which took a position and a size. And a size has a width and a height, as you might imagine. And this area has an initializer, the position and the size. And we've exported this through the previous mechanism. When we create a new area without any parameters here, JavaScript core just goes, OK, no, that's fine. And bear in mind, all of this JavaScript is JavaScript that will run and work without errors by default. It will just assume that you meant, oh, OK, give it no value, no values for these things. So JS area will get a nil position and a nil size. This might be fine in Objective-C, but in Swift, they come through, and obviously this causes a crash because we're not expecting optional values. We're not expecting nil to be given to any of these things. And this leads to this kind of horrendous state of affair where you have to sanitize the input. So now you kind of expect a JS position which is optional and a JS size which is optional, and we've got to check to make sure they exist before creating our actual area struct value and initializing on that. And if not, we're just going to return nil and hope that the person knows what they're doing in JavaScript and can work that out. So another scenario could be that you create a size with a width of 10 and a height of 20, and you try and create an area with that size as the position. Now, obviously, looking at this is an error, but this is also something a user could enter. And to be honest, most users are terrible and probably will try to do this. The worst ones will try to hack into your app anyway and try and find backdoors, right? So again, this will come through to the JS area type as a size and a size, and Objective-C doesn't care because it's just like, well, whatever, I got something. And Swift doesn't like the fact that a size is given for a position, which is a completely valid thing for it to want. So then you go back and you go, okay, well, I've got to do some more sanitization. You've got to then say that all of your inputs are any, and optional any's, because that's basically what JavaScript can give you. It can go, well, I'm going to take anything. And in fact, I might take nothing. And you're going to have to deal with it. So then you've got to check to make sure that the position is a JS position, and the size is a JS size, and then convert them to your native types, and then make an area and initialize. More fun is if you have an extension on area which gives you the center position. It's a read-only property. It's fairly simple. Hopefully my math is correct, because I didn't actually compile this. I just typed it straight into the slide. No, it's not. Y is missing. Great. That's fine. So imagine that this is correct and lovely. And I've said y equals position.y plus size.height over 2. This is going to give you the center of that area. We can extend the JS area type and the protocol to add the method, to add the property, to be a read-only JS position. And remember that JS area has an area which is our area type. So we can just create a JS position from its center, and that's wrong as well. I'm sorry. I'm sorry. That should say area.center. And hopefully that makes sense. My confusing slides are, yeah. So it turns out that in JavaScript, if you've got a read-only property, the evaluation of that is perfectly happy to try to set on that property. So now it's like, well, okay, JavaScript can throw you anything that can be nil at things that don't even want it. I mean, the saving grace here is that nothing happens. But if the user's got that property, and it's kind of the JavaScript's run, they might expect to have the center changed. So you probably want to start throwing up some errors for some of these things. And JavaScript core and JS context have a way and a mechanism of dealing with this. So this is a very small snippet that you can kind of apply to all of these examples. So if we change our center property to have a getter and a setter, even though our original type only has the getter, in the get instance we can just return the area center, and on the setter we can get the current context that's executing. So the weird thing is that this code is being executed within JavaScript core's kind of execution. So there's a JS context existing that you can get. And there's a property on that called exception, and that takes a JS value. So normally this would be an exception thrown by JavaScript at runtime. But you can insert your own exceptions, provide a message into that context, and that will stop execution of the JavaScript, which is really valuable. Right? It means that the user's code just stops. There's no more execution, so they're in an invalid state, so they won't go any further to do any more damage, basically. It also means that if you've got a console type thing, then this message will get printed out to the console, and the user will be like, oh, okay, cool, center is not settable. Now I know. Because they're not going to read your documentation, that's for sure. They're users, come on. So just a mention on threading. And this might be the first instance where Swift works really, really well with JavaScript. Because threading occurs on the thread that you call the JS context. Okay, it's completely synchronous within that thread. So what you can do is offload it to another thread and just pass across all the values. And you know they're all thread safe because they're value types. So you pass across all the values from your app. Maybe your document is a value type as well. And yep. And that allows you to basically not block the main thread with this JavaScript that's running, which might allow you to do some cool things like present alerts if the user types in, alert with a message, and allows you to implement those things that perhaps JavaScript developers kind of expect anyway. I'm going to talk quickly about the code editor, because this is the other half of the problem. One half is getting all of your types into the app. The other half is this code editor. And I've kind of mimicked what my first kind of hit of this looks like. We're using the text edit app, but effectively just the UITEXTVIEW. We all kind of know what this looks like. It gives a rubbish experience. There's no code completion. There's no code highlighting. There's nothing. You're writing stuff and hoping. And I got really frustrated with this because I am not a JavaScript developer. I don't really know JavaScript. I'm kind of fumbling my way around this. So to try to write JavaScript without any kind of safety mechanism to make me know that this is correct was really, really difficult. So a couple of options exist. And I started looking into basically providing a JavaScript-based JavaScript editor using a web view. And all of these cases, they've got really, really good online implementations that you can just try out and use and just see whether it's going to fit your app. So there's MONACO, which is the basis for Visual Studio Code from Microsoft. To me, it looks a bit Visual Studio-y, so I decided not to use it. There was a lot of things that I thought were a bit too much for my case. There's also ACE, which is really good. And I will say that all of these are completely fast. I was a bit dubious about just slapping one in a web view, but they are really fast, and they're really cool, and they just do the code completion. And it's completely fine. And then there's CODEMIRROR, which is what I ended up using. It's kind of cleaner by default. A lot of these allow you to completely style them into the way that you want. So you could perhaps have either different themes that users could select, or just provide your own theme that matches your app style. So if you've got a dark theme in your app, then you can make it dark, for example. And just a quick kind of look at the HTML that you'll need for this is just to, I think a couple things here which are really interesting. The viewport stuff on the HTML, to make it non-scalable so that it doesn't try to kind of shrink as the lines grow longer, but to wrap. Just in general, that's a really good practice for HTML. But we just get the CODEMIRROR JavaScript, we add it in, and it's a text area. So if you don't know HTML, a text area is just a typable area, and it takes that and kind of shoves it off screen somewhere, or to a corner or a single pixel, and replaces that element with the full-fledged CODEMIRROR editor. And here's just an example of some of the ways you can customize it. You can add in line numbers, whether it's line wrapping. You can give it a mode, so it will automatically handle loads of different languages. In this case, I just want to handle JavaScript. It has bracket matching, so if the user types an open brace, then you'll get a closed brace. And if you kind of toggle over the last one, it will highlight the first one. So kind of basic things that you expect in a code editor. And on a Swift side, imagine we've got a web view that's got this stuff in it. You can grab the editor, which is the CODEMIRROR editor. You can get the value for it, which will come down as a string. You can make sure it's there, and you can do stuff with that. And as I said, this is really cool because it's really easy to add. And you'll go down this rabbit hole that I did if you start adding stuff like this, and realizing that there's so many JavaScript things that you can add, to the point where I've got linting in there, I've got code completion, and it feels like a proper IDE environment in my app. And the best thing is, it's only like 43,000 lines of JavaScript, which is almost nothing, I think, in JavaScript terms. There's definitely a lot more JavaScript I'd want to add, but yeah, I mean, these are 43,000 beautiful lines of JavaScript. Never thought I'd say that. And this is the kind of thing that you get out of it. This is the editor. And the other thing that's really cool about this is that this is running in Safari, as you can see. But it's got all of the code completion, and you can just kind of test it out. Linting means that you'll get errors, and you can just kind of, in Safari on the Mac, you can hover over the errors, and they'll present themselves so that users know. But this isn't the default style, so there's some custom CSS on here to make all the colors look nice. I replaced that image with an SVG, so it's really simple to just get in there and customize. I've also got auto-completion in this, so it auto-completes on the standard JavaScript stuff, and you can provide your own definitions of types with JSON, and I think that's called, there's a tool called Turn, which works with CodeMirror. I think it's done by the same guy. They work really nicely together, but the definitions look something like this. So here we've got a position, and that type says that's the constructor function, effectively. So when you type in position, open brace, it will start doing the auto-completion for you and say what type is expected. So hopefully users won't run into the problems where they're given the wrong type, but if they are, you can provide an error. But this is kind of inline documentation for those things. And then if you put a period after a position value in JavaScript, it can auto-complete the X and the Y. And that's about it. I can show off the code editor if people want. Should I do that? Just to give you a kind of real... Bear with me. Can everyone see that? That's very tiny here. Is that very tiny for everyone? Too small? Let's change it to that. And is that better? So this is the kind of thing, like, that was just me tabbing to autocomplete, and then you get the values here. Now if I run this, that's going to give me a load of errors because I'm a JavaScript noob. So I don't have center on here on this version, actually. But you can get the exposition. So we can do something like this. This size is kind of has this proportional value, so that means that the width and the height stay the same if you resize one of the values. So if I were to change the width to be half the size, hopefully, this is going to be a bad demo if this doesn't work. Yeah. So because it's proportional, this size has been resized to 6 wide and 11.5 high, just because I sized the width. I've added a console.log function, which basically just prints to this console. So that console is just a UITEXTVIEW, which I dump stuff to every time you call console.log. And that printout there at the bottom is the description of the Swift value, which is quite cool. Like, to me, that's like, hey, you've jumped through loads of hoops, and you're actually just using your core tested types, rather than all of this stuff in the middle, which is just boilerplate, basically, to get that stuff to work. But yeah, and hopefully it can do a lot more cool things, but this is a short demo. And that's it, really. Has anyone got any questions?
Wait a second.
Could you give just list maybe some examples of the real world scenarios? Because, I mean, that was a great example of the concept, but I'm sure we can do some more meaningful stuff.
Yeah, this is the big problem with this. Sorry, is this right? It's like there's no real great examples of how this works in the real world. I think the best examples I have are on the Mac. So apps like almost all apps on the Mac are scriptable, and that's allowed for this ecosystem to kind of happen. But ones that have taken real advantage of it, like Sketch for the Mac, and they've allowed their users to make plugins, and those plugins are now sold. So not only is the app profitable, but they're making users able to make money off the things they're making in the app. And arguably that's only happened because it's on the Mac. I'd like to think that could happen on iOS as well if we had the applications that people would want to use for those things. And I think with iOS 11 we've got a lot more reason to provide this kind of functionality. So we've got a file system now. Let's make it so that users can really do powerful things with their apps rather than just not. My app issues, I've had a lot of people come up and say, hey, can you support X system? I'm kind of in the point where I'm wondering whether it's worth wrapping a lot of those core types in JavaScript and saying, okay, well, I've got this JavaScript API that you can interact with. If I call you and say, hey, get all the issues for this account, then you can provide me with a list of issues and I'll display them on the screen, and then you can save that as a plugin that's kind of acts as this back end. So I think that's feasible and that's technically feasible. Whether or not that would take off is still to be decided, I think. But definitely the front end scripting in terms of Sketch, I think that's proven that there is a use case for it. We just need the apps to kind of come around and say, users want this.
Okay, do you think that you could have any potential problems with your app being rejected for using such scripting within the app?
Yeah, maybe. My understanding is that Apple are kind of okay with JavaScript, and they've always been okay with running some amount of custom JavaScript. What I've got right now, this demo, I haven't put it onto to test that. Actually, you saying that, I probably should. Before I go any further with it. But in my mind, at its current state, it's user-generated, user-inputted JavaScript. And I think they should be okay with that. If you start downloading random JavaScript bundles, then maybe that's where they'll have a problem. But it would be good if they didn't.
Anyone else? Any more questions?
That's good, because now I know who to give the cups to. Sorry, I forgot to mention there were cups for questions, if anyone else has one.
Yeah, perfect. That's it. Thank you very much.